Hi everybody, this is a review of the solutions to the homework on chi-square. So for your first problem, remember that you were supposed to make up this table. And so it's whether there's two nominal variables is your major, humanities, fine arts, social science, natural science, and don't know yet, and whether or not the person read the Times, the LA Times. And so here we go. And so the first step is to have the actual observations. And so based on what was written above, your table should look like this. I've put in the totals for the rows here. The rows being read the LA Times, not read it. You could flip it the other way, it doesn't matter. It just will look different, but your numbers will be the same in the end. And then the columns are the majors. And so there's a total for those also right here. And if we add these four together, it comes out to 48. If we add these two together, the rows, it also comes out to 48. So looks like we're in good business here. So here's the actual observations from our sample. So now the next step is we calculate our frequencies. So remember that the formula is this. So for each cell, we want to take the sum of the columns times the sum of the rows times n. I had capital N. It actually doesn't matter. Actually, small n is better because it fits in there. It doesn't matter because there's no difference between n and capital N here. So we do those calculations. So for reading Times and humanities, fine arts, we have 9 people here in this row, and we have 11 people in this column. So you might say, well, why do you have 9 and 11? I have 11 and 9. It's the same thing. It doesn't really matter. So take the column, take the rows, multiply those, and divide by 48. There's 48 total people in our sample. The expected value is this. So you do that for every cell. So social science and reading the LA Times. We have 9 people reading the LA Times total in our sample. We have 25 social science majors. So 9 times 25 divided by 48. This is the expected value for that cell. Same thing for down here. I'm not going to do all of them. I'll just highlight a couple. So natural science major and not reading the LA Times. So we have 39 people in our sample not reading the LA Times. And we have 5 natural science majors. So 39 times 5 divided by 48, total number of people. This is the expected value for that cell. So go ahead and make sure, check your calculations here for each of your cells' expected value. And then our next step is our little table here where we take the O minus E, square that, and we divide it by E for every column. So reading the LA Times and humanities, fine arts. So I'm gonna take it like this. I'm gonna be reading LA Times, humanities, fine arts, social science, natural science. So I'm gonna go down that row. So we have 5 people who actually read the LA Times and were humanities, fine arts majors in our sample. We expected 2.06 people there. So O minus E is 2.94. We take 2.94 times 2.94, we get this. And then we take this value and we divide it by 2.06. So we get 4.20. And we do the same thing for every cell. Let's look at the not humanities, I'm sorry, not reading and their humanities and fine arts majors. So this one, not reading and humanities fine arts major. So that's 6 who are actually in that cell. We expected 8.94, so we get a negative 0.294. We had 2.94 less people than we expected in that cell. 2.94 times 2.94 is 8.6436. If you round it up to the second decimal place, that's fine. So there might be some small rounding errors. If you don't have the exact numbers in the end, it's a rounding error. As long as you're within, several hundredths of a point, it's a rounding error. So 8.6436 divided by the expected 8.94, it's 0.97. So these are the numbers that you should have in your table here, and these are the ones that we're going to add to get our chi-square. So we add those together, and our chi-square is 8.68. So you can look at your appendix or the table that we have online. I'm just going to change that. So degrees of freedom, remember it's r minus 1 times c minus 1. R is rows. We had 2 rows. They read the times or not. So 2 minus 1 is 1. So how many columns do we have? Well, we have how many majors? We have 4 categories of majors. So it's 4 minus 1 is 3. So 3 times 1 is 3. 3 degrees of freedom. Basically because it's this, basically because we only have a 1 here. So 3 degrees of freedom, we go to our table, 0.05 right here. 3 degrees of freedom, 7.82. So 7.82 is our critical value for 3 degrees of freedom at the 0.05 alpha level. And so actually our calculated value is greater than the table value, so we reject the HO. So we actually have to also then kind of look what's going on. Well, what's going on? Where's the biggest numbers in our chi-square? There's only 2 that are above 1. So I would sort of use the 1 as a cutoff at the very least. And so this is the big one. This is the biggest one. It accounts for almost half of our chi-square. And so the reading the LA Times and being Humanities Fine Arts is the cell we need to look at. We need to look here where the direction is. So there's actually more Humanities and Fine Arts majors who read the LA Times than we expected. And then this one is small, but we can also mention it. So this is the cell for reading the Times and social science majors. So again, we have to look here. So there's fewer social science majors reading the LA Times than we would expect based on just simple probability. Those seem to be the 2 things going on. So let's write this up. So one's major significantly relates to reading the LA Times, chi-square. We have the degrees of freedom. We have the sample size, the chi-square here. We rejected the HO, so P is less than 0.05. In the lecture, I had a table, so you can refer to table 1 if you want to. Table 1 is up there already. Table 1 for observations. And then a rough inspection of the table suggests that Humanities and Fine Arts majors were more likely to read LA Times than expected. In addition, social science majors were somewhat less likely to read the LA Times than expected, period. So chi-squares are pretty straightforward and pretty simple. And so here's the second one. And so we have, there's a thing about a memory test, but that's just to distract people from what we're really trying to do. So people waiting in rooms or being in rooms, and then at some point in time we ask them what their mood is, and we see whether the color of the walls of the room affects people's moods. And so these are counts of people. So this is the color of the paint on the walls. And this is the mood that people reported that they were in. And so we're asking whether the paint on the walls seemed to be related to the mood that the person reported. And so this is the observed. And so make sure to do the totals for the rows, totals of the columns. I'll have that in the next one here. So your totals, it's all 45 right here. And that makes some sense. Why is it 45 here? That seems weird. Well, in the examples that we had before, we were dealing with essentially predictor variables. Things that had to do with somebody's life, we didn't manipulate it. So whether somebody was married or not married, or whether they were secure, preoccupied, dismissing, or what major they were, and whether they read the LA Times, all these things are just stuff about people's lives. We didn't manipulate it. It's predictor variables. So in this case, this is actually an experimental study because we want to make sure to put a third of people in off-white room, a third in the dark gray, a third in the bright yellow. So since we're manipulating this variable of paint, that's our IV, that's why we have equal 45s here. And we add those up and it's 135, but make sure you add the columns also. So we had 38 people who said they're happy, 25 people who said they're sad, and 72 who are neutral. We add those together, that's also adding up to 135. So here we can calculate our expected values. So off-white happy, we have 45 off-white people, at least people who are in the rooms, the color of the rooms, and then we have 38 happy people in the whole sample. So columns times rows, doesn't matter what order it's in, divided by number of people, 135. Our expected value is 12.67. We can do the same thing for everything. I'm just going to do an example in each row. So a dark gray room, how many dark gray rooms? 45 people in those. And then sad, we had 25 people who are sad. So column times row, divided by n, the expected value is 8.33 for that cell. Same thing for like the bright yellow. So we had 45 people in the bright yellow room. We had 72 people who said they had a neutral mood. Column times row divided by n. Expected value is 24. So we do that for each of our cells, each of our 9 cells. Sorry about that. So there's our expected values. Now it's just simply doing our last little table. So if we go white and happy, so 12 people were in a white room and said they were happy. We expected 12.67 to be in that cell, and it's negative 0.67 for O minus E. 0.67 times 0.67, 0.4489. If you round it, that's fine. So we take 0.4489, divide by 12.67, 0.04. So we do this for every cell. Gray and happy. There was 9 people in the gray room who said they were happy. We expected 12.67 of those type of people based on probability of the rows and the columns. And so there was 3.67 fewer people in that cell than we expected. Take 3.67 times 3.67, we get 13.4689. We take 13.4689, divide that by 12.67, the expected, we get 1.06. So we do this for every cell. We have 9 cells, so we have 9 of these rows. We add up this final column. When we add that up, that is our chi-square. Our chi-square is pretty small in this case, it looks like. 4.45, I'm not sure if it's going to be significant, but let's see. And so you can use your appendix or you can use the web page I gave you. So we have 3 rooms. Remember, we have 3 rooms. We have 3 rooms of different colors. And then we have 3 moods that people report that they're in. They're either happy or sad or they're neutral. So we have 3 rows and 3 columns. So 3 minus 1 times 3 minus 1. That's 2 times 2 is 4. So 4 degrees of freedom right here. 0.05, 4 degrees of freedom, 9.49. So 9.49 is our critical value with 4 degrees of freedom and an alpha of 0.05. So our calculated value is actually less than the one from the table, so we fail to reject the HO. So this is really easy because we don't look at our cells now because we have a non-significant factor. Color of the room did not affect mood. Chi-square, degrees of freedom, sample size equals 4.45, comma NS, not significant, that's all we say. So just like the F test, if it's significant, go look at those cells and see what's going on. If it's not significant, you just say there's no relationship between these two variables. Make sure you say what those variables are, give the chi-square statistics, and that's it. So that is the video for the homework. If you have any questions, please come to one of the live Q&A sessions on Zoom. I'll talk to you later.